Welcome back to our Math 171 video series. In this video, we'll investigate nonlinear systems of equations. That's any system that has a second power in it. Our system this time is x squared plus y squared equals 16 and y equals x minus 4. We call this a nonlinear system because of the second powers in line 1. Previously, we've done systems of equations that have just x and y, but they were not second power. However, if you have a graph of a nonlinear system, your work is fairly straightforward. We can just read the points off the graph where the graphs intersect. We can see from this graph that there are two places the blue line touches the red line. Those will represent our solutions to this system. We'll mark the points in red on the graph. We'll label them point A and point B. Now, point A is directly on the y-axis. Anytime you are directly on the y-axis, it means the x-coordinate is 0. And if we look closely at point A, we can see that its y-coordinate is -4. Therefore, we'll say point A is at 0, -4, remembering always to write the x first, always write the y second. Point B is similar, except for it's on the x-axis. Points on the x-axis have a y-coordinate of 0. We'll write that for point B, the y-coordinate is 0. We may be able to see that on the x-coordinate, that the x is 4. Because here's x equals 0, here's x equals 2, and we're the same distance away from 2 that we are from 0, so this coordinate would be 4. Therefore, point B is located at 4, 0. Therefore, these would be your solutions to the nonlinear system. When we write solutions to a nonlinear system, we must write ordered pairs. This is similar to how you would write solutions to any other systems of equations. Now, imagine we didn't have that graph. How could we solve this system using algebra? We could solve this similarly to how we could solve any other system of equations. We look for single letters and try to get that single letter by itself. We can see in this system, in line 2, we already have y by itself. Therefore, we could take that y from line 2 and substitute it everywhere else y occurs. Since we know y is equal to x minus 4, we can locate y and replace it with x minus 4. So what we'll do is go to line 1 and replace the y. We will get a new line 1. We'll have x squared plus y squared equals 16. However, that y will now become x minus 4, and we'll place it in these parentheses. Now we can simplify. However, to simplify, we might notice that we have a binomial inside of a square. Anytime you have a binomial inside of a square, we write the binomial twice and multiply with the FOIL method. Therefore, our new equation will be x squared plus x minus 4 times itself, x minus 4, equals 16. Now we'll use the FOIL method on the x minus 4's. X times x will give us x squared. X times -4 will give us -4x. -4 times x will give us another -4x. And -4 times another -4 will give us positive 16. We can now combine the like term. Now we combine the like terms, that's the -4x's, and we'll end up with x squared minus 8x plus 16 equals 16, and this extra x squared that we had previously will come down as well, and we'll have x squared plus x squared minus 8x plus 16 equals 16. We can also combine the x squareds to give us 2x squared. We'll bring down all of the other terms, and this will give us minus 8x plus 16 equals 16. Now that we have this second power equation, we'll try to simplify and solve it. Now to solve the second power equation, let's try to get all of our terms onto the left. Therefore, the 16 that is on the right will have to move. When you move the 16 to the other side, it will become negative 16. This will allow the positive 16 and the negative 16 to cancel, and this will give us just 2x squared minus 8x equals 0. Now that we have everything on the left side and a 0 on the right, we can try to factor the left side. You may be able to see that they have an x in common, so we can definitely pull an x out. You may also see that both of the numbers are even, and so we can also pull a 2 out of both of the constants. So if we take 2x squared divided by 2x, we'll end up with just x. That will be the first member of our parentheses, and then we'll have negative 8x divided by 2x. Negative 8x divided by 2x gives negative 4. And so now we have 2x times x minus 4 equals 0. Now that we've factored the left side, we can now set each piece equal to 0. We now have 2x equals 0 and x minus 4 equals 0. When you have a number multiplied by x, you can divide. We'll take 2x divided by 2 and 0 divided by 2. 2x divided by 2 just gives x, and 0 divided by 2 will give 0. Therefore, we know one of our x's is 0. For our other x, we'll have x minus 4 equals 0, and this will give us x equals positive 4 if we move the negative 4 over. These are our two x solutions. With a nonlinear system, though, it is not enough to get the x's, we'll need to know what y's go with them. Therefore, the problem does not end here. We have to figure out what y goes with these x's using our equations in our system. We will move our x's onto the next page and try to accomplish that. With our x equals 0 and our x equals 4, we can put them in somewhere in the system to figure out what y is. However, line 2 seems a lot more simple than line 1. So for that reason, I will select line 2 and place the x's there. Line 2 says that y is equal to x minus 4. Everywhere we see x, let's place one of our solutions. Our first solution was x equals 0. We'll place that in for x, and this will give us y equals 0 minus 4, which is negative 4. Therefore, our first solution, we will write x comma y. The x we used was 0, and the y that we found was negative 4. This will be our first solution. We'll do the same thing with the other x. We know that y equals x minus 4, and so we'll plug 4 in for x. If we subtract, we'll get 0. Therefore, our solution, again, is x comma y. The x we used was 4, and the solution we got for y was 0. This will be our second solution. With those points in mind, 0, negative 4, and 4, 0, let's go back to the graph. We see that our first point, point A, was indeed 0, negative 4. We'll also see point B is 4, 0. These are exactly the same solutions that we found when we solved the system algebraically. And so this is how we find the solution to nonlinear systems if we don't have a graph. Thank you for watching, and we'll see you again soon.